Today we're going to graph from standard form instead of from vertex form. Vertex is form is the one that told us whether the vertex moved right or up or down or whatever. Okay, and this is standard form. Okay, when we graph in standard form, we're going to find the vertex, we're going to draw the axis of symmetry, we're going to use the y-intercept and a point symmetric to the y-intercept to get a good graph for our parabola. Okay, to start off, we're going to find the vertex. Because this is in standard form, we're going to use the vertex formula. So I'm going to indicate what A, B, and C are. In this case, A is 2, B is -8, and C is +5. To find the vertex, remember we do H equals -B over 2A. So what is B? B is -8, so -8 turns this to +8 over 2 times A. A is 2. I'm going to go ahead and simplify this. 8 divided by 4 is 2. So the x-coordinate of the vertex is 2. Okay, to get the y-coordinate of the vertex, I'm going to plug the 2 back into the original equation. So 2 times x squared minus 8 times x plus 5. Okay, and then I'm going to go ahead and evaluate this. Make sure you do your exponent first. So 2 times 4 minus 16 plus 5, which is 8 minus 16 plus 5. You're welcome to put that in your calculator. That would be -8 plus 5, which is -3. Okay, so the first piece of information is that the vertex is at 2, -3. So I'm going to go ahead and go to my graph and mark 2, -3. If you don't have graph paper, you can do a sketch as long as you level the points. So from the origin, x is 2, y is -3. So this is going to be my vertex down here. Okay, and I'm going to label it because some of you don't have graph paper. Okay, let me see what the next guidance it gives me. Okay, the next thing it asks me is to draw the axis of symmetry. The axis of symmetry is the vertical line. It always runs through the vertex. So I can go ahead and draw it in. Okay, the equation for the axis of symmetry is x equals, from the graph, I can see it hits the x-axis at 2, or if I look at the vertex, I can see the x-coordinate is 2. But either way, the axis of symmetry is x equals 2. Okay, what we're going to add now is the y-intercept. Now the y-intercept can be easily found from the standard form. Okay, I'm going to tell you what it is. Okay, the y-intercept is always the c value. Okay, it's always 0, comma, and then I can use my c value. So let me go back here. I wrote A, B, C. C is 5. It's also this number at the end, just like on a line. So my y-intercept is 0, 5. It'll always be 0, comma, whatever the c value is. And that's because if I plug in 0, I'm left with the constant at the end. So I'm going to go ahead and graph the y-intercept on my graph. If you don't have graph paper, you can sketch it. Y-intercept +5. So on the y-axis, I'm going to go to +5 and put my point. Okay, this is pretty good, but we're going to use the symmetric point to get one extra bonus point. And then we're going to sketch our parabola using those 3 points. Okay, remember the symmetric point is the matching point across the line of symmetry. So if this is the y-intercept, the symmetric point is over on this side. Okay, because this is 2 units from the axis of symmetry, if I go 2 more units, I'm going to find the exact location for the symmetric point. So the symmetric point is this point right here. Okay, the ordered pair for that point would be 1, 2, 3, 4, 1, 2, 3, 4, 5. So at 4, 5 is my symmetric point. And those 3 points are enough to get a good graph. So I'm going to go ahead and sketch my parabola. Make sure it's curved because a parabola is a curve. The vertex is in the middle. I see the y-intercept and I see the point symmetric to the y-intercept on the other side. Okay, that's going to be the method we use to graph, putting everything together. Okay, let's try example 2 now. Okay, I can see from the given graph, this is in standard form from highest degree to lowest degree. I'm going to go ahead and find the vertex. So let me write what A, B, and C are. So in this case, A is 1, B is 6, C is 4, and now our C is actually useful to us when we get to the y-intercept. Okay, to find the vertex, H equals -B over 2 times A. Okay, B is 6, A is 1. Negative 6 divided by 2 is negative 3. So the x-coordinate of the vertex will be negative 3. To get the y-coordinate, I plug my x value in. So x squared plus 6x plus 4. And I just found h to be negative 3. Okay, negative 3 to the second power is positive 9 minus 18 plus 4. If you want to put that in your calculator, you can. 9 minus 18 is negative 9. Negative 9 plus 4 is negative 5. So the y-coordinate of the vertex is negative 5. So I'm going to go ahead and plot negative 3, negative 5 on my graph, and you can sketch it. 1, 2, 3, 1, 2, 3, 4, 5. Okay, I'm going to plot it. I'm also going to label it because if you're doing a sketch, you have to label it because your sketch is not drawn to scale. Okay, now the axis of symmetry goes through the vertex. It's dashed. It always starts with x equals. So in this case, it's going to be x equals negative 3. And again, I can get that from the graph because that's where it's intersecting the x-axis. Or I can get it from the x-coordinate of the vertex. Okay, the y-intercept. The y-intercept is always the c value, or it's the number at the end. So I can either look at the constant at the end of the equation, or I can look at my c value, but it's always 0, 4 in this case. So on the y-axis, 1, 2, 3, 4. On the y-axis, I go to positive 4. I'm going to label this, especially if I'm sketching it, because remember we did the sketches before. As long as you label it, it's fine. Okay, so now the last thing is I just need the symmetric point to the y-intercept. This is the y-intercept, which means there's a matching point over here somewhere. Okay, let me count. To get from the y-intercept to the line of symmetry, that's 1, 2, 3 units. 1, 2, 3 units more will get me to my symmetric point, which is over here. And just look at it. It should look like it's even. So I went 3 and 3 to the left, so I actually went negative 6, and the y-coordinate is positive 4 there. Okay, those 3 points are enough to get a good sketch. So I'm going to sketch my curved parabola. Okay, and that's the entire thing. Okay, in class we're only going to do 2 examples. I'm going to do one more example for the video in case you need an extra example. Okay, this last example, you don't have to write it in your notebook, but I want to do one with a negative a value so you can see what that will be. So a is negative 3, b is negative 6, and c is 4. And this is in standard form already. So h equals negative b. Oh, but b is negative 6, so positive 6 over 2 times a. Okay, let's evaluate this. 6 divided by negative 6 is negative 1. So the vertex will be negative 1 comma something. Okay, to get the k value, I'm going to plug my negative 1 into my equation carefully. Okay, remember to do the exponent first. So negative 3, negative 1 squared is positive 1. Negative 3 plus 6 plus 4. 6 plus 4 is 10. 10 minus 3 is 7. You are welcome to use a calculator there. My vertex is going to be at negative 1 comma 7. So I'm going to go ahead and sketch that point. Negative 1, 1, 2, 3, 4, 5, 6, 7. Pretty high. And I'm going to label it, especially if I'm sketching it. Okay, the axis of symmetry goes through the vertex. It's dashed. It always starts with x equals when we write the equation. So x equals, in this case, it equals negative 1 from the vertex or from the graph. Okay, the y-intercept is the c value. You can either look at the constant at the end or you can get it from here. So the y-intercept is 0, 4. So on the y-axis, I'm going to go to 0, positive 4, which is up here. Okay, one more. I just need a third point. The third point is going to be my symmetric point to the y-intercept. So if this is on the right side of the axis of symmetry, there has to be a matching point on the left side of the axis of symmetry. Okay, so let me see. It's going to go here. I can see that. That's going to make it look even. The pink point was 1 unit from the axis of symmetry. If I go 1 more unit, I end up at the green unit, the green point. The coordinates for this are going to be negative 2, 1, 2, 3, 4, negative 2 comma 4. Okay, and let me label my y-intercept as well, 0, 4. Okay, then I'm going to go ahead and sketch my parabola. 3 points is enough. This happens to be opening in the downward direction, which makes sense to me because if the A value is negative, this will open in the downward direction. So I should expect that to happen if it looks like that.